Hello and welcome to this lecture. In this lecture, we'll look at how to manage certificates and what the certificate API is in Kubernetes. So, what have we done so far? I, as an administrator of the cluster, in the process of setting up the whole cluster, have set up a CA server and a bunch of certificates for the various components. We then started the services using the right certificates and it's all up and working. I'm the only administrator and user of the cluster, and I have my own admin certificate and key. A new admin comes into my team. She needs access to the cluster. We need to get her a pair of certificate and key pair for her to access the cluster. She creates her own private key, generates a certificate signing request, and sends it to me. Since I'm the only admin, I then take the certificate signing request to my CA server, gets it signed by the CA server using the CA server's private key and root certificate, thereby generating a certificate and then sends the certificate back to her. She now has her own valid pair of certificate and key that she can use to access the cluster. The certificates have a validity period. It ends after a period of time. Every time it expires, we follow the same process of generating a new CSR and getting it signed by the CA. So we keep rotating the certificate files. So we keep talking about the CA server. What is the CA server and where is it located in the Kubernetes setup? The CA is really just the pair of key and certificate files we have generated. Whoever gains access to these pair of files can sign any certificate for the Kubernetes environment. They can create as many users as they want with whatever privileges they want. So these files need to be protected and stored in a safe environment. Say we place them on a server that is fully secure. Now that server becomes your CA server. The certificate key file is safely stored in that server and only on that server. Every time you want to sign a certificate, you can only do it by logging into that server. As of now, we have the certificates placed on the Kubernetes master node itself. So the master node is also our CA server. The kubeadm tool does the same thing. It creates a CA pair of files and stores that on the master node itself. So far, we have been signing requests manually. But as and when the users increase and your team grows, you need a better automated way to manage the certificates, signing requests, as well as to rotate certificates when they expire. Kubernetes has a built-in certificates API that can do this for you. With the certificates API, you now send a certificate signing request directly to Kubernetes through an API call. This time, when the administrator receives a certificate signing request, instead of logging onto the master node and signing the certificate by himself, he creates a Kubernetes API object called certificate signing request. Once the object is created, all certificate signing requests can be seen by administrators of the cluster. The requests can be reviewed and approved easily using kubectl commands. This certificate can then be extracted and shared with the user. Let's see how it is done. A user first creates a key, then generates a certificate signing request using the key with her name on it, then sends the request to the administrator. The administrator takes the key and creates a certificate signing request object. The certificate signing request object is created like any other Kubernetes object using a manifest file with the usual fields. The kind is certificate signing request. Under the spec section, specify the groups the user should be part of and list the usages of the account as a list of strings. The request field is where you specify the certificate signing request sent by the user. But you don't specify it as plain text. Instead, it must be encoded using the base64 command. Then move the encoded text into the request field and then submit the request. Once the object is created, all certificate signing requests can be seen by administrators by running the kubectl get CSR command. Identify the new request and approve the request by running the kubectl certificate approve command. Kubernetes signs the certificate using the CA key pairs and generates a certificate for the user. This certificate can then be extracted and shared with the user. View the certificate by viewing it in a YAML format. The generated certificate is part of the output. But as before, it is in a base64 encoded format. To decode it, take the text and use the base64 utilities decode option. This gives the certificate in a plain text format. This can then be shared with the end user. Now that we have seen how it works, let's see who does all of this for us. If you look at the Kubernetes control plane, you see the Kube API server, the scheduler, the control manager, etcd server, etc. Which of these components is actually responsible for all the certificate-related operations? All the certificate-related operations are carried out by the controller manager. If you look closely at the controller manager, you will see that it has controllers in it called as CSR approving, CSR signing, etc. that are responsible for carrying out these specific tasks. We know that if anyone has to sign certificates, they need the CA server's root certificate and private key. The controller manager service configuration has two options where you can specify these. Well, that's it for this lecture. Head over to the practice desk and play around with the certificates API. I will see you in the next lecture. Hello and welcome to this lecture. In this lecture, we look at kube configs in Kubernetes. So far, we have seen how to generate a certificate for a user. We have seen how a client uses the certificate file and key to query the Kubernetes REST API for a list of pods using curl. In this case, my cluster is called myKubePlayground, so send a curl request to the address of the Kube API server while passing in the pair of files along with the CA certificate as options. This is then validated by the API server to authenticate the user. Now, how do you do that while using the kubecontrol command? You can specify the same information using the options server, client key, client certificate, and certificate authority with the kubecontrol utility. Obviously, typing those in every time is a tedious task, so you move this information to a configuration file called as kubeconfig, and then specify this file as the kubeconfig option in your command. By default, the kubecontrol tool looks for a file named config under a directory .kube under the user's home directory. So if you create the kubeconfig file there, you don't have to specify the path to the file explicitly in the kubecontrol command. That's the reason you haven't been specifying any options for your kubecontrol commands so far. The kubeconfig file is in a specific format. Let's take a look at that. The config file has three sections: clusters, users, and contexts. Clusters are the various Kubernetes clusters that you need access to. So you have multiple clusters for development environment, or testing environment, or prod, or for different organizations, or on different cloud providers, etc. All those go there. Users are the user accounts with which you have access to these clusters. For example, the admin user, a dev user, a prod user, etc. These users may have different privileges on different clusters. Finally, contexts marry these together. Contexts define which user account will be used to access which cluster. For example, you could create a context named admin@production that will use the admin account to access a production cluster. Or I may want to access the cluster I have set up on Google with the dev user's credentials to test deploying the application I built. Remember, you're not creating any new users or configuring any kind of user access or authorization in the cluster with this process. You're using existing users with their existing privileges and defining what user you're going to use to access what cluster. That way, you don't have to specify the user certificates and server address in each and every kubecontrol command you run. So how does it fit into our example? The server specification in our command goes into the clusters section. The admin user's keys and certificates goes into the users section. You then create a context that specifies to use the myKubeAdmin user to access the myKubePlayground cluster. Let's look at a real kubeconfig file now. The kubeconfig file is in a YAML format. It has API version set to v1, the kind is config, and then it has 3 sections as we discussed. One for clusters, one for context, and one for users. Each of these is in an array format. That way, you can specify multiple clusters, users, or contexts within the same file. Under clusters, we add a new item for our Cube Playground cluster. We name it myCubePlayground and specify the server address under the server field. It also requires the certificate of the certificate authority. We can then add an entry into the users section to specify details of my kubeadmin user. Provide the location of the client's certificate and key pair, so we have now defined the cluster and the user to access the cluster. Next, we create an entry under the context section to link the two together. We will name the context myCubeAdmin at myCubePlayground. We will then specify the same name we used for cluster and user. Follow the same procedure to add all the clusters you daily access, the user credentials you use to access them, as well as the context. Once the file is ready, remember that you don't have to create any object like you usually do for other Kubernetes objects. The file is left as is and is read by the kubecontrol command, and the required values are used. Now, how does kubecontrol know which context to choose from? We've defined 3 contexts here. Which one should it start with? You can specify the default context to use by adding a field current context to the kubeconfig file. Specify the name of the context to use. In this case, kubecontrol will always use the context dev_user at Google to access the Google clusters using the dev_user's credentials. There are command line options available within kubecontrol to view and modify the kubeconfig files. To view the current file being used, run the kubecontrol config view command. It lists the clusters, contexts, and users, as well as the current context that is set. As we discussed earlier, if you do not specify which kubeconfig file to use, it ends up using the default file located in the folder .cube in the user's home directory. Alternatively, you can specify a kubeconfig file by passing the kubeconfig option in the command line like this. We will move our custom config to the home directory, so this becomes our default config file. So how do you update your current context? So you've been using myCubeAdmin user to access myCubePlayground. How do you change the context to use prod user to access the production cluster? Run the kubecontrol config useContext command to change the current context to the prod user at production context. This can be seen in the current context field in the file. So yes, the changes made by kubecontrol config command actually reflects in the file. You can make other changes in the file, update or delete items in it using other variations of the kubecontrol config command. Check them out when you get time. What about namespaces? For example, each cluster may be configured with multiple namespaces within it. Can you configure a context to switch to a particular namespace? Yes. The context section in the kubeconfig file can take additional field called namespace, where you can specify a particular namespace. This way, when you switch to that context, you will automatically be in a specific namespace. Finally, a word on certificates. You have seen path to certificate files mentioned in kubeconfig like this. Well, it's better to use the full path like this. But remember, there's also another way to specify the certificate credentials. Let's look at the first one, for instance, where we configure the path to the certificate authority. We have the contents of the ca.crt file on the right. Instead of using certificate authority field and the path to the file, you may optionally use the certificate authority data field and provide the contents of the certificate itself, but not the file as is. Convert the contents to a base64 encoded format and then pass that in. Similarly, if you see a file with the certificate's data in the encoded format, use the base64 decode option to decode the certificate. Well, that's it for this lecture. Head over to the practice exercises section. Practice working with kubeconfig files and troubleshooting issues. Before we head into authorization, it is necessary to understand about API groups in Kubernetes. But first, what is the Kubernetes API? We learned about the kube API server. Whatever operations we have done so far with the cluster, we've been interacting with the API server one way or the other, either through the kubectl utility or directly via REST. Say we want to check the version. We can access the API server at the master node's address, followed by the port, which is 6443 by default, and the API version. It returns the version. Similarly, to get the list of pods, you would access the URL api/v1/pods. Our focus in this lecture is about these API paths, the version, and the API. The Kubernetes API is grouped into multiple such groups based on their purpose, such as one for APIs, one for health, one for metrics and logs, etc. The version API is for viewing the version of the cluster as we just saw. The metrics and health API are used to monitor the health of the cluster. The logs are used for integrating with third-party logging applications. In this video, we will focus on the APIs responsible for the cluster functionality. These APIs are categorized into two: the core group and the named group. The core group is where all core functionality exists, such as namespaces, pods, replication controllers, events, endpoints, nodes, bindings, persistent volume claims, config maps, secrets, services, etc. The named group APIs are more organized, and going forward, all the newer features are going to be made available through these named groups. It has groups under it for apps, extensions, networking, storage, authentication, authorization, etc. Shown here are just a few. Within apps, you have deployments, replica sets, stateful sets. Within networking, you have network policies. Certificates have the certificate signing requests that we talked about earlier in this section. So the ones at the top are API groups, and the ones at the bottom are resources in those groups. Each resource in this has a set of actions associated with them, things that you can do with these resources, such as list the deployments, get information about one of these deployments, create a deployment, delete a deployment, update a deployment, watch a deployment, etc. These are known as verbs. The Kubernetes API reference page can tell you what the API group is for each object. Select an object, and the first section in the documentation page shows its group details. v1 core is just v1. You can also view these on your Kubernetes cluster. Access your kube API server at port 6443 without any path, and it will list you the available API groups. And then within the named API groups, it returns all the supported resource groups. A quick note on accessing the cluster API like that. If you were to access the API directly through curl as shown here, then you will not be allowed access except for certain APIs like version, as you have not specified any authentication mechanisms. So you have to authenticate to the API using your certificate files by passing them in the command line like this. An alternate option is to start a kubectl proxy client. The kubectl proxy command launches a proxy service locally on port 8001 and uses credentials and certificates from your kubeconfig file to access the cluster. That way, you don't have to specify those in the curl command. Now you can access the kubectl proxy service at port 8001, and the proxy will use the credentials from kubeconfig file to forward your request to the kube API server. This will list all available APIs at root. So here are two terms that kind of sound the same: the kube proxy and kubectl proxy. Well, they're not the same. We discussed about kube proxy earlier in this course. It is used to enable connectivity between pods and services across different nodes in the cluster. we discuss about kubeproxy in much more detail later in this course, whereas kubecontrol is an HTTP proxy service created by kubecontrol utility to access the kube API server. So what to take away from this? All resources in Kubernetes are grouped into different API groups. At the top level, you have core API group and named API group. Under the named API group, you have one for each section. Under these API groups, you have the different resources, and each resource has a set of associated actions known as verbs. In the next section on authorization, we can see how we use these to allow or deny access